Okay, so the first thing is plotting the points. So what you notice here is we have just the blank screen. Anytime you want to move it, switch it into the coordinate plane system, you can change the grids on it. So the way to do that is to access this graph command. All right, so if you access this graph command and you choose show grid, or you can choose the type that you pick, either one should give you the square grid as the default. So now you have your coordinate plane inserted into your sketchpad. And notice the two red dots are what actually define this plane. So you can't just delete them. You actually have to, if they are in your way, you can't hit delete. You can hit Control H if you highlight them and just hide them to get them out of the way. But if you try to delete them, the whole grid will disappear. All right, so if I ask you to plot these points, what you might be tempted to do is to take the point tool and then find somewhere right about here is where, oops. So if you wanted to plot these 3 and then -2, so right about here would be your point. However, this is not dynamically tied. So as I move my grids, it doesn't lock into place and it's not a precise measurement. So what we need to do is figure out a way to actually plot them so they're locked in place on the grid. And the way to do that is also located under graph. And if you just choose the plot points command, you can just type them in. So 3, -2, plot it, and you see that it appears in the correct spot. Do the same thing with -1, 5, plot it, it also appears up here. Okay, so the thing with these is as you move it, those stay locked in place. So now you can actually identify properties associated with these because it's a very precise measurement. That those points are located at the exact spots and they'll stay there. All right, so if you wanted then to find the slope of the line between these. Okay, so finding the slope here, if you constructed a line that contains these 2 points, so highlight the 2 points, choose construct line. And once your line is highlighted or selected, if you choose measure, you can pick between slope and equation. So I'm going to go slope first. So our slope is -7 or -1.75. And if I wanted to find or actually let's confirm this really quickly. So if we use just the counting method for our slope, we count from B to A, go 1, 2, 3, 4, 5, 6, 7. So we go up 7, then we go over 1, 2, 3, 4. So our slope winds up being -7/4. Is that equivalent to -1.75? Yes. So they're equivalent. They're the same thing. Now, if what we want to do is measure the equation or identify what the equation of this line is, again, if we highlight the line, go also to measure and choose equation, it gives us the equation of that line. Notice the equation is written in decimal form. Right? So that's going to play a role here in just a second. But you have your equation. Okay, so the last step would be how do you put your equation in standard form? Okay, so if it asks you to put it in standard form, okay, one way that you could possibly do this, if you use the decimal form here, you might think, well, if I multiply every term in my equation by 100, I'd get rid of my decimal. So 100y is equal to -175x plus 325. The problem with this, even if you were to remove this back into the standard form, so the x's are positive, they come first. X's and y's are on the same side of the equation, and the constants all alone on the other side. And this is not the standard form that I would be looking for because it's not simplified. Okay, what you may need to do, and again, it might not be as simple a fraction as these are, but you might need to actually do part of the standard form ones by hand. So again, if we counted our slope, we get the fractional form of our slope. So we see that this is -7/4. So what we know is our equation is y is equal to -7/4 x plus, and here we have 3.25. Well, 0.25 is what fraction form? Fourths, right? So this is really 3 1/4. And if you convert it into just an improper fraction, so single fraction, 3 times 4 is 12 plus 1 is 13/4. And so this then allows you, instead of multiplying everything by 10, you can find your LCD is a smaller number. I'm sorry, by 100. You can see your LCD is a smaller number, and you can go ahead and perform that. So 4y equals negative 7x plus 13. Move all the terms to one side with the variables. So your final form would be a positive 7x, the 4y, and then the 13 stays alone. And so this would be what you were looking at in the standard form. Okay, so be very careful on that. I want it to be accurate. I want you to have the smaller number. Don't use the decimal form. Okay, convert those decimals into fractions before you begin the standard form. All right, questions on that?